let's review our vocabulary for our coordinate planes. So the coordinate plane has two number lines that intersect at a point called the origin. The origin is in the middle here. Remember, that's the ordered pair 0, 0. That's where all of our points start from, in the middle, and then depending on if our x and y are positive or negative, that tells us what direction we're going on our x number line and our y number line. The horizontal number line is called the x-axis. So here's my x-axis. I'm going positive to the right, and to the left I have negative values. My y-axis is my vertical axis, so that's going up and down, right? As I go up, those are my positive y values. As I go down, those are my negative y values. Notice that these divide our coordinate plane into 4 different sections that we call quadrants. So it goes counterclockwise, where everything's positive, that's quadrant 1. Then we have quadrant 2, quadrant 3, and quadrant 4. So it goes counterclockwise, and we do 1, 2, 3, and 4.
Come to the office. Braden, Cruz, please come to the...
The location of a point in the coordinate plane is given using an ordered pair. An ordered pair of numbers, for example, like 4, -3. You've seen ordered pairs before. Remember, it's always the x coordinate and then the y coordinate. X comes before y in the alphabet. X comes before y in our ordered pair. We can label the origin, the axes, and quadrants. Right? Those are all our vocabulary words when we're looking at our coordinate plane. If I wanted to graph 4, -3, well, my x value is 4. I would go 4 to the right. My y value is -3, so I'd go 4 right and 3 down. And here's where the point 4, -3 would be on my coordinate plane. If we had the point 5, 0, that's where we have an x value and y is 0. So whenever you have an x value, that's on your x-axis. If we had the point 0, 4, well, now they have a y value. So x is 0. We're not going left or right at all. We're just going up 4, and that would be a point on our y-axis. Okay, let's talk about a couple more vocabulary words. For an equation with two variables, like the slope-intercept form we've been looking at. So an equation in two variables is, for example, a lot of times we write it as y equals mx plus b. A pair of values, x and y, that make an equation true is called a solution of the equation. Each solution is an ordered pair. Okay. The value of x is written first, the value of y is written second. Each solution can be represented as a point on the coordinate plane. So 4, -3 could be a point or a solution for the equation -2x plus 5. And it's a solution because if I were to substitute 4 into this problem, -2 times 4 plus 5, if I get -3 as my y value, that's what makes it a solution. -2 times 4 is -8. -8 plus 5 is -3. When x is 4, y is -3. That's a solution to the linear equation y equals -2x plus 5. So I could represent that solution on my graph for -3. The set of all points representing the solutions is a graph. So we could draw a line representing all of the solutions. An equation in two variables has an infinite number of solutions. So there's an infinite number of points on the graph. If I graphed this line, here's the line with a slope of -2 and a y-intercept of 5. And if I graph this line, this represents the infinite solutions for this equation. If the graph of an equation in two variables is a straight line, like the one you see, we call that linear. Linear means a straight line. It means it has a constant rate of change. This line is decreasing by -2. Every solution can be represented as a point on the line. Let's look at another equation. For example, the equation y equals 2x plus 5 is a linear equation because its graph is a line. One solution of this equation is 3, 11. If I were to substitute 3 in for x, 2 times 3 is 6, and 6 plus 5 is 11. So when x is 3, y is 11. That's what it means to be a solution. Your input that goes with your output is what makes up a solution. 2x plus 3y equals 90 is another linear equation because it would have a graph that is a straight line. So 2x plus 3y equals 90 is still linear, but this is in standard form. And most of the time, when we've looked at linear equations, we've looked at our slope-intercept form, our y equals mx plus b. So we just have different forms, but they're both linear. In a linear equation, the highest power of either variable is the first power. We don't write it, but these are both to the first power. They have an exponent of 1. That's what makes them linear. If they had any other exponent, they would not be linear. There's our vocabulary for our coordinate planes.